Welcome to The Explainer. Today, we're tackling a genuinely massive question. What exactly is artificial intelligence? If you're completely new to this and feeling a bit overwhelmed by all the tech jargon floating around lately, take a deep breath. You are in the exact right place. We're going to demystify the absolute foundation of AI together, and I promise you, by the end of this, you'll go from confused to completely clear, and we're going to do it with zero overwhelming jargon. Let's get into it. Here's our roadmap for today. We'll hit 6 quick steps: demystifying artificial intelligence, software versus machine learning, the language of data, the learning loop, types and examples, and then we'll wrap it up with the Day 1 recap. Section 1. Demystifying artificial intelligence. Okay, before we even touch machines or computers, we have to define intelligence itself. Put simply, intelligence is just the ability to acquire knowledge and apply it to solve a problem. Think about a toddler. They touch a hot stove, they acquire the very painful knowledge that it hurts, and they apply that new skill by making sure they never touch that stove again. That's intelligence in action. Now, if you take that exact same ability, learning a skill and applying it, and give it to a machine, that is artificial intelligence. It's really that simple. We're simulating human intelligence processes using computer systems. We just want computers to perceive, learn, and solve problems the way our own brains do. Section 2. Software versus machine learning. This is an absolutely crucial distinction. We need to compare normal software and older rule-based AI against modern machine learning. Normal software relies entirely on strict human-written if-then rules. A programmer literally types, if the user clicks this button, then open this menu. The computer has zero actual intelligence. It's just blindly following a recipe. But machine learning, totally different ballgame. Instead of hard-coded rules, it actively finds patterns in data to make decisions entirely on its own. But that begs a pretty massive question. If a human isn't typing out the rules, what does an AI actually do? And what does learning really mean for a machine with no biological brain? How does it figure things out? Well, it all comes down to the absolute secret ingredient of modern AI: data. Section 3. The language of data. You simply cannot have machine learning without data. Data represents the raw facts of our world: statistics, text, numbers, images. But raw data by itself is usually a bit messy. When you take all those raw facts and organize them into a clean, structured format, you get a dataset. You can think of a dataset as the official textbook we hand to the AI so it can start studying. Let's look at how a dataset is actually built. It basically has 2 distinct parts. The inputs, or the specific columns describing an object, are called features. Here, our features are size and color. The final answer we want the machine to learn to predict is called the label, which in this case is the fruit type. The entire goal is to feed the AI the features, meaning the size and color, and have it successfully guess the label, meaning it figures out if it's looking at an apple or a lemon. Section 4. The learning loop. So how does it actually study that textbook? Inside the AI software, there are mathematical mechanisms called parameters. I want you to think of parameters as a giant dashboard of invisible knobs and dials inside the machine. As the AI tries to figure out the hidden patterns connecting the features to the labels, it can literally reach in and twist these dials to adjust its calculations. Building directly on that, we have weights. If parameters are the dials, weights are the exact mathematical values those dials are set to. They tell the machine exactly how much importance to give a specific feature. Going back to our fruit example, as the machine learns, it might adjust its weights to realize that the color yellow is a way stronger indicator than size when identifying a lemon. So it gives color a heavier weight. Now, when the machine first starts twisting those dials, it's gonna mess up. A lot. If it guesses wrong, that's called an error. It's like throwing a dart and missing the board entirely. But just knowing you missed isn't quite enough to help you improve. That's why AI relies on something called loss. Loss is the precise mathematical calculation of exactly how far off the prediction was. It tells the machine, hey, you didn't just miss. Your dart landed exactly 4.2 inches away from the bullseye at a 45-degree angle. That exact measurement is what lets the machine confidently adjust for its next throw. All of this comes together to create the basic machine learning loop. This is the absolute heartbeat of AI. It's a relentless, continuous cycle. Step 1, the machine makes a guess. Step 2, it calculates the loss, figuring out precisely how wrong that guess was. Step 3, it reaches in and adjusts the weights, tweaking those internal dials. And step 4, it repeats over and over, sometimes millions of times, until the loss is incredibly tiny and the machine is highly accurate. That math loop right there, that's what we mean when we say a machine is learning. Section 5, types and examples. It's super important to understand that everything we interact with today is what we call narrow AI. Narrow AI is designed to do one specific task brilliantly, like playing chess or translating a language, but it cannot operate outside that single domain. A chess AI has absolutely no idea how to cook you dinner. On the flip side, we have AGI, or Artificial General Intelligence. This is the futuristic concept of a machine that truly matches human-level cognitive abilities across literally any task. AGI is still science fiction for now, but it's the ultimate holy grail of AI research. Looking at the major AI areas out there right now really highlights how narrow AI powers some incredible tech. Machine learning is the foundation for all of it. Then you have NLP, or natural language processing, which lets machines understand text. Computer vision lets them understand images and video. Speech AI is what powers the voice assistant on your phone. Robotics lets AI physically interact with the real world. Recommendation systems are those unseen algorithms deciding your next Netflix binge. And of course, generative AI, which takes what it's learned to create brand new text, images, or audio from scratch. Section 6, Day 1 Recap. Here is your complete Day 1 mental map. Think of this as your ultimate cheat sheet for how data flows through learning loops to create intelligent software. Just look at the logic. Intelligence is applied knowledge. AI gives this capability to machines. Machine learning does this by replacing strict rules with data patterns. Those patterns are found in datasets that use features to predict labels. And the whole system optimizes itself through the learning loop, constantly adjusting weights to reduce its loss. When you lay it all out like this, it makes perfect sense. So to quickly recap everything we've covered in today's explainer, AI isn't magic at all. It's just math, data, and immense computational power. It learns through a continuous process of trial and error, tweaking its styles until it gets the right answer. And finally, today's AI is strictly narrow, incredibly focused on mastering specific individual tasks. I want to leave you with a thought to chew on this week as you notice AI working in the background of your life. Knowing what you now know about how an AI learns from datasets, calculates its loss, and adjusts its weights to find hidden patterns, what patterns in your own daily routines, your shopping habits, or the media you consume do you think a machine could accurately predict next? Keep that in mind the next time an app suggests the exact thing you were just thinking about. Thanks for hanging out with me for this explainer, and keep that curiosity alive.